305. Okay, so let's see who's here. So Mia's here.
What page?
305. Your math book. Serenity's here. Elizabeth's here. Keaton's here. Hale is virtual.
305.
305, yes. Lillian's here. Natalie's not here. Ms. Polk is here. Ellie's here. She's absent. Catherine, Ellie, Keaton, Catherine. Virtual. Sylvia's virtual. Okay, my list is in there. You should at least have your barrier up, Elizabeth, or move Mia's over. There you go. Okay, 3, 4. Lance. Oh. Okay, Mia's here. Stanley, has Stanley gotten here yet? Not yet. Stanley, Serenity's here. Elizabeth's here. Keaton's here. Lillian's here. Is Natalie here today?
No.
Okay. Ms. Polk is here. Ellie's here. Catherine, Sophia. Lillian's here. Keaton, Serenity, Kale. Okay. Kale. Catherine, and anybody else show up? There's Natalie. Okay. Okay, that is attendance. Okay, so page 305 in your math book. We've been talking about graphing ratio tables. So we're at the top of the page, 305. Okay, so here we go. The table shows the total time it took Samir to read 0, 1, 2, and 3 pages of the book. The table also lists this information as ordered pairs, and the ordered pairs are set up as pages to minutes. Graph the ordered pairs and describe the pattern of the graph. Okay, so this is our X, this is our Y, this is our ordered pair. Right? And we have these two number lines that intersect, right? And this is pages. So this side is pages, this side is minutes. Okay? So I want you to go ahead and plot or put these specific points, these ordered pairs on this coordinate grid. Okay? I'm going to give you like 2 minutes, and I want you to put these points over here on this coordinate plane. Okay? And then then we'll see how you do. Hey Google, set a timer for 2 minutes.
Okay, 2 minutes. Starting now.
So you need to graph 4 points. 4 points. Right here. Hey Google, stop. Okay, so we have these 4 points. We have 4 ordered pairs, right? And our first one is 0, 0. So here's 0 and here's 0. So our first ordered pair is right here. So we have that one. Then our next ordered pair is 1, 4. So we're going to go to the right to 1 and we're going to go up to 4 and we're going to have to kind of guesstimate because we don't ever actually have a line for that. So we have that. Next ordered pair is 2, 8. So we're going to go over to 2 and we're going to go up to 8. Again, we're going to have to kind of estimate again. Okay, so we have 2, 8. And then our next ordered pair is 3, 12. So we're going to go over to 3 and go up to 12. When we're going to have to guesstimate again. So we'll just put it right there. That's about probably where 12 is. Okay. So then if we actually take a ruler and connect it, right? And I like to put my pin on that point and then line it up with the other one. Okay, so that's our line. And then it says describe the pattern in the graph. Okay. So we're going to write the graph shows that Samir read one page every 4 minutes. Okay. So that's what this graph is representing. We can even go along this line and we can even find more information. If he read more, we could actually figure out that he could read 5 pages in 20 minutes because that information is going to be right along this line. So we can predict what some other data might be just by looking at different points on this line, because this is ratio, right? We're comparing pages to minutes, different attributes. Okay. So let's go on to the next one. We have Ken's Home Supply charges $5 per foot for fencing, and Wayne's Warehouse charges $6 per foot for fencing. Make a table for each store that shows the total cost of 1, 2, 3, and 4 feet of fencing. List the information as ordered pairs, feet of fencing, total cost. Okay, so we have two ratio tables that we need to complete and to create the ordered pair. So I'm going to do the first one. So Ken's costs $5 per foot, and Wayne's is $6 per foot. Okay, so my first one's going to be, right, my cost for 1 foot is $5, so I'm going to put 5 there, and my ordered pair is going to be 1, 5. So Wayne's Warehouse, right, is $6 per foot, so I'm going to put a 6 there, and my ordered pair is 1, 6. So I want you to complete the rest of the ratio tables, okay? And then I will come back and check, okay? Hey, Google, set a timer for 3 minutes.
Sure, 3 minutes. Starting now.
Okay, I need you to finish the ratio tables. So calculate the cost, calculate, and then to create the ordered pair. Hey, Google, stop. Okay, so we're going to complete our ratio tables. And if you notice, this very first one is 1 to 5. This is actually a unit rate, right? because you have one. You actually had one up here too. This is also a unit rate. Okay, so if 1 foot is $5, then I'm going to take 2 times 5 and I'm going to get 10. And then my ordered pair is going to be 210. And then 3 feet, I'm going to do 3 times 5, that's 15. And my ordered pair is 315. Okay. Then my next one, 4 feet, $5 each. 4 times 5 is 20. So the cost is $20, and my ordered pair is $420. So let's go over to Wayne's side. We know that his cost per foot is $6 per foot. This is a unit rate, right? Because it's just it has a 1. So if I had 2 feet, 2 times 6 is 12. And my ordered pair is 212. And then 3 feet would be 3 times 6, which is 18. And my ordered pair would be 318. Okay, and then 4 feet would be 4 times 6 is 24. And my ordered pair is 424. Okay, number 3 says predict the cost at each store for 9 feet of fencing. Explain your reasoning. Okay, well, at Ken's, let's do this. This is Ken's, and this is Wayne's. Right? We know that the unit rate, or 1 foot, is 1 foot is equal to $5. So if 1 foot is $5, then I just have to multiply 5 times 9, right? And 5 times 9 is 45. So the cost for 9 feet would be $45. At Wayne's, my unit rate is 1 foot. 1 foot. What am I doing? 1 foot is equal to $6, right? This is my unit rate. This is a unit rate. Okay, so I'm looking for the cost for 9 feet. So I'm going to take 6 times 9, and that is equal to 54. So that's $54. Okay. So now number 4, it says graph the ordered pairs for each store on the same coordinate plane. Okay, so I have a coordinate plane right here, and I want you to go ahead and graph these 4 ordered pairs on this coordinate plane, and then I want you to graph these 4 points on this coordinate plane. Okay, and just remember, this is fencing, this is feet, and this is cost, right? Okay, so 4 minutes. I want you to graph all those. So you're going to have a total of 4 points for Ken's, 4 points for Wayne's, and then I want you to label the line. Which one's Ken, which one's Wayne? Hey Google, set a timer for 4 minutes.
Okay, 4 minutes. Starting now.
Hey, Google, stop. Okay, so let's go ahead and plot. Let's start with Ken's first. Okay, so our ordered pair, we're going to always start with X. We're going to go to the right. We're going to go to 1, and you're going to go up to 5. So that's right here. And then our next ordered pair is 2 10s. So we're going to go over to 2 and go up to 10. So that's right there. Then we're going to go to 3 and go up to 15. So that's right there. Then we're going to go to 4 feet of fencing, and we're going to go up to 20, which is the cost over here. Now we're just going to take our ruler and we'll line it up. And then we're going to label this as Ken's. Okay. So now let's go ahead and plot the points for Wayne's. So our first ordered pair is 1 6. So we're going to go over to 1 and go up to 6, which is going to be a little bit above 5. So we have that one. Then we have 2 12s. We'll go over to 2, go up to 12. That's going to be right about there. Then we're going to have 3 18s. So we're going to go across to the right to 3. We're going to go up to 18, which is, we're going to guess, right about there. Okay. And then 4 and 24. So we went to the right to 4, and we're going to go up to 24, which is going to be probably right about there. Okay. So then we're going to get our ruler. Okay. And this is Wayne's. Okay. So then it also says graph the order pairs for each store on the same coordinate plane. We did that. Using tables and graphs, write a few sentences comparing the rates of amount charged per foot of fencing for each store. How is this shown on the graph? Okay. So as the number of feet increases, right? So as our feet increase, the cost, which is this column, the cost at Wayne's warehouse increases at a faster rate than the cost at Ken's. So if you look at the chart here, see, this is Wayne's is higher here. Here, this is 10, this is 12, 15, 16, 17, 20, 24. So this is increasing at a faster rate than at Ken's. And then we can also, if we look at the graph, we can see that this line is steeper, right? So that means that it has a greater ratio, or it costs more money because the line is more steep than Ken's, which is far below that. So we can say that the cost of at Wayne's is shown on the graph as a steeper line. Okay. Okay, so let's turn the page. Turn the page, number 6. Okay, Patty's Pies made 2 peach pies using 10 cups of peaches. So there's 2 pies, 10 cups of peaches. They made 3 pies with 15 cups of peaches, and they made 4 pies using 20 cups of peaches. Predict how many cups of peaches would be needed to make 9 peach pies. Okay, so we have a ratio here, right? So we have the relationship is pies, right, to cups of peaches. So this is our relationship, right? And we're going to create a ratio table, right? So we know the first one is, I'm going to give a little bit of space. So the first one is 2 pies to 10 cups of peaches. The next one is 3 pies to 15 cups of peaches. And the next one is 4 pies to 20 cups of peaches. Okay. So let's keep going with that. Okay. Let's see. We can continue. We can notice that this goes up by 5 on each one, and this goes up by 1. So what if we did 5 pies? 5 pies would be 25 cups of peaches, right? 6 pies is going to be 5 more. That's going to be 30 cups of peaches. 7 pies is going to be 5 more, which is 35 cups of peaches. 8 is going to be 5 more, which would be 40. And if we had 9 pies, it'd be 5 more, it would be 45. Okay? So we know by extending our ratio table that and let's do this. If I back up 1, right? If I divide this by 2, I get 1. And if I divide 10 by 2, I get 5. So my unit rate is 1 to 5. So we're going to say unit rate is 1 to 5, right? So for 9 pies, you would need 45 cups of peaches. Okay. Okay. Number 7, use multiple representation. The golden rectangle is a rectangle in which the ratio of the length to the width is approximately 1.618 to 1. This ratio is called the golden ratio. Why do they call it the golden ratio? Let's look that up, just for curiosity. Golden ratio, also known as the golden section, golden mean, or divine proportion in mathematics, the irrational number 1 plus the square root of 5 divided by 2, often denoted by the Greek letter, is approximately equal to 1.68. Okay. So in mathematics, two quantities are in golden ratio if their ratio is the same as the ratio as their sum. So it's the ratio of their sum to the larger of the two quantities. So I guess this number shows up many times in geometry, art, architecture. Okay. Okay. Well, that's it. That's interesting. Never heard that before. Okay. So we're on number 7. It says use multiple representations. The golden rectangle is a rectangle in which the ratio of the length to the width is approximately this, 1.6821. This ratio is called the golden ratio. Okay. So table, make a ratio table to show the approximate lengths of a golden rectangle given widths that are 1, 2, 3, and 4 units. List the information as ordered pairs, length, and width. Okay, so we have our table here, right? It's telling us that the widths are 1, 2, 3, and 4. So let's go ahead and put 1, 2, 3, and 4. Okay. And then if this relationship, so our length, so the width is 1, 2, 3, 4. So then our length would be 1.618, right? And our ordered pair would be 1.61821. Okay. So now this is our unit rate. So we know we're just going to take 2 times 1.618. Okay. And I'm going to do this for you. So that makes that 3.236. So this is 3.23622. Then we're going to do 3 times 1.618, which is going to give us 4.854. And then that gives me an order pair of 4.854 to 3. And then I'm going to do 4 times 1.618, which is 6.472. So my ordered pair is 6.47224. Okay. So we filled out our table, graph the ordered pairs on the coordinate plane. Okay. Okay. Well, and if I want, and let's look at our coordinate plane, right? It doesn't have, it's just these whole numbers. So we're going to have to guesstimate to do this. Where are we on time? Okay, we'll probably finish this problem and that'll be it. Okay, so my first ordered pair is 1.618 to 1. So I'm going to go over 1.1. That's a little bit more than 1.5. So this would be, here's 2. This would be 1. right? So 0, 1, 2, 1.6 would be somewhere right about here. And we're going to go up to 1, which is right here. So we're going to put a dot right there, about. Okay, so we've got that one. The next one is 3.236 to 2. So 3 would be here and a little bit more. We're going to go that and go up to 2. So we're going to put that right about there. Okay, then we have 4.854, which is almost 5 to 3. So we're going to go up to here, which just makes it that point right there. So we have that one. Then we have 6.472 to 4. Uh-oh. That's 1. Oh. Should have moved this over. That's 1. This is 2. So 3. 3.2 to 2. Then 4.854 to, yeah, I did that right. And then 6.45, it's almost 6.5. That's 7, so that'd be right about there, up to 4, which would be right about there. Okay, so that's our line. Analyze, how does the area of each rectangle change as the dimensions change? So if you look at the numbers, you can notice so basically we're going to summarize this because they actually went and calculated the area, which we're not going to do, but the areas increase at a slower rate as the dimensions, or their length and width, increase. So the area increases at a slower rate than the dimensions. As the dimensions increase, the area increases at a slower point. We're okay. Well, we're right at 11:50. Okay, so my online people, you may log off, go to period 5. Okay. Recording.